The next graph that we're going to be looking at is for the function f of x equals x cubed, looking at a cubic here. So I'm going to plug some values in. First of all, negative 3 to the third power is negative 27. 3 negatives make a negative. Negative 2 to the third is negative 8. Negative 1 to the third is negative 1. 0 times 0 times 0 is still 0. 1 times 1 times 1 is 1. 2 cubed is 8. And 3 cubed is 27. Okay, with a cubic, it's important to note that when you cube a negative, it stays negative. So I'm down here at negative 27, negative 8, negative 1. We go through 0, 0. We're at 1, 1, 2, 8, and 327. Okay. Now, also keep in mind here that the scale has been stretched very much here, that we do not have equal spacing on x and y. So this would be much, much taller and steeper if I was to square this grid out instead of keeping it a rectangle. All right. Now, for our domain and our range on our cubic, we're hitting all the x values just like we were for the quadratic. So our domain is going to be the whole interval, negative infinity to infinity, or all real numbers. But our range this time also will hit all the negatives and all the positives, so the range is going to be the same for the cubics, negative infinity to infinity. Okay. Now, with cubics, there is much more variation than there is with quadratics. Quadratics always have a parabola as their shape, but the shape for cubics can vary a lot more. There's no name for the shape of a cubic because it can have so many different types of shape. Okay. This last one right here is the graph of the traditional ones. You can see what it would look like if I had it square scale. And then you can see that there are abilities for it to come back up, come back down in the middle. Any of these graphs would be the graph of a cubic. Okay. They do have some commonalities, though. So what do they have in common? One of the things is that the ends of a cubic always point in opposite directions. So that's going to be tied to your range. We're always going down on one side and up on the other. It could be reversed, down left versus down on the right, but you are always going to have them up on opposite ends. That's part of the range of a cubic always being negative infinity to infinity. For the quadratics, we couldn't say the range was going to be the same thing every time, but we could say they were going to have a vertex and that the range was going to go in one direction only.